today we're going to start our chemistry unit. It's the first thing in chemistry we're doing this spring semester. It's going to start getting good. Before we actually get started in depth with chemistry, we need to learn about a process first. It's going to help us out throughout the year. And that's going to be endothermic and exothermic. So you haven't pulled your interactive notebook out yet, your folder, and go to this page, go ahead and do so right now. So we're going to talk about endothermic and exothermic. Now, you probably don't know what these are yet. It's fine. Let's start off by reading the essential question, which is, when the test tube is heated up by the Bunsen burner, does this represent an exothermic or endothermic process? I know it says reaction, but it's process. Explain your reasoning to include which direction the energy is flowing. Now, we're actually not going to answer this part today. We'll answer this part tomorrow. So you turn your page over, you actually see this on the back page. We're not doing a summary. Instead, we're going to do another smaller experiment tomorrow to see the process. You have to give us a claim, you have evidence for it, and your reasoning using your notes from today. All right, so y'all should have a dotted line midway on your paper. Mine does not for some reason, but a dotted line. We're going to start on this first part on the top half, okay? Let's talk about three things you should already know, hopefully, and that's this guy, a solid, liquid, and of course in the air, gas. All right, so I'm going to go ahead and do a quick little illustration right up here. I'm going to draw me a little solid. Okay. Just to make it easy for me to remember it, I'm going to draw a little ice cube right here. A little ice cube. It's a solid. So obviously ice is solid. Next, I'm going to draw a liquid. So I'm going to draw like a little cup right here. Or it could be a beaker with a little bit of liquid in there. That's fine. The last one will be gas. Now it's kind of hard to draw gas, so I'm going to draw another beaker here with some water in it and steam coming out. All right, got the picture. This will be solid, liquid, and this will be gas. In this case, steam. All right, so we're going to think, how do we get from solid to liquid? I know this seems like very elementary school thing, 6th grade, 5th grade, 4th, but we're going to go more depth today. How do we get from solid to liquid, liquid to gas? All right, you might think, well, we just heat it up, but what's actually happening? All right, so to help illustrate this today, I'm going to add a little arrow on the bottom, like this arrow here, and that's the direction heat or energy moves. So in order to get from a solid to liquid, right, we're going to have to add energy to it. If we just set a piece of ice down, it's going to start melting. I'm sorry, you can't see that. Why is it melting? Because energy from this outside air in the environment is entering the ice cube, and it's going to make it melt. Or let's just say if I got a match here, and don't do this. So you light a match, you hold this ice cube over the lit match, the heat energy from that match is going to start melting the ice. Right? Really quickly at that. Okay. So we have heat or energy enter the system. So I'm going to draw little arrows going in. Heat is entering. So that's not confusing. Let me put a bigger arrow like that. And so energy is entering the ice cube. When it does this, it's changing the phase or changing the state. So from solid to liquid. All right, now we got a liquid. How do we keep on make this into a gas or steam? It would add again more energy to it. So in order to go to this one, we have to add more energy. We can do this by when we do our ramen noodles on the stove. We put the stove on there, we turn the gas on. The gas is making a flame. That flame is heating up the liquid and it's boiling, making it into steam. So you get into a liquid, adding more energy into it. All right. I mean, it's that simple, right? So now we're going to think, these two terms right here, what does this mean? Well, we're going to start off with the part of energy entering the system. When it enters the system, we're going to call this endothermic. It's endothermic process. Think of entering, also enter. They go together. So when energy enters the system, it's endothermic. All right, now let's use this bottom section right here. So we entered right over here. Let's do it where it's exiting. All right, so I'm going to start off again with the same phases, but I'm going to reverse them a little bit. I'm going to start off with a little bit of a steam going off right here. Gas or steam. And draw the next one as a liquid. And draw the next one as a solid. Of course, I should have drew it first before I wrote down the word, but it's okay. All right, so we got gas, liquid, solid. Now we're going to do the same thing. The arrows represent the direction that it moves. So the direction energy moves. Okay, so instead of this time it going in, we see what happens when it goes out. So when energy is leaving the system. When it does this, we call this condensation. You've probably seen this before. Let me see if I can find my example here. Let's say if you have a soda, and I pulled out of the fridge, it just hasn't got that cold yet. Maybe I'll see a little bit on the camera. When you pull it out of the fridge, it starts to sweat on the outside. When you get the soda, it starts to sweat outside. It's not the soda coming through the bottle, but it's that the air around it, the gas, is condensing and making, you saw that, it's making a liquid. So here is a test tube. It's filled with a little bit of ice water. And you start seeing, it's really hard to see on the camera, you start seeing the condensation forming. So it was completely dry. Let me see if I can get this paper here. I might be able to see it. Kind of hard to see. Maybe I'll see the liquid showing off a little bit. That's coming on the outside of this test tube. Basically, it's getting cold. The energy is, sorry, the gas is going into this one, so the energy is leaving, turning into condensing to a liquid. So the energy is leaving the gas, turning to a liquid. It's called condensation. Now, if we have, let's say, a liquid, and we put it in the freezer, when we do that, it turns into a solid. So again, the liquid, sorry, energy is leaving, like so. Energy is leaving, it's turning to a solid. So when it's leaving, it's exiting. So exit, you can't see that right there. Exit, the same as exothermic. So if the energy is exiting the system, it's exothermic. Okay. If you're confused, just hold on a bit. We'll make it work. All right, so let's go back to the first one here. We have endothermic. Remember, endothermic is entering the system. It's coming together. So let's say the example. This is when heat. Let me switch colors so you can see it a bit better. This will be when heat or energy moves from the surroundings into the system. All right, so when we say it's moving from the surroundings, that could be, say, if we have a stove and it's like on fire, like the gas is burning, and it's heating up the water. That stove, the energy from that part is the surroundings, and it's going to the water. That water will be the system. Right, so in this case, the surrounding is something from the outside, and the system is the actual object itself. So to show an example of this, I have some, it's a little heating gel. You usually get like for catering or something like that. And if I was to ignite it, you might be able to see that on camera, I'm not sure. All right, so we have a little bit of a heat coming up from it. Now, let's say if I had a test tube, let's see this test tube here, and I was to sit on top. Now, at first it's not going to heat up that quick, but if I hold it here for about a minute or so, it might start boiling. In this case, the energy is leaving the canned fuel and entering the water, heating the water up. In this case, this is a endothermic process because this part is gaining energy. Okay, push that to the side and safely cap it. There we go. So that's an example of endothermic. And what about exothermic? All right, it's yeah, actually, let's do some fun ones of this. So exothermic. Let's just say I have some cabbage juice, which is right here, because who doesn't have cabbage juice sitting around? And some let me see what I got over here. Some calcium chloride. So calcium chloride is the same stuff that's in dampered. Now, don't do this at home. It has potential dangers, so just watch it happen. Now, since I'm going to deal with some chemicals, I'm going to use my safety glasses. So always use safety. Now I'm going to get a thermometer here. All right, so I got my little CPR thermometer right here. I'm going to set it to Celsius, and I'm going to see what's happening. So I have this cabbage juice. It's about 24 degrees, 25 degrees Celsius. All right, so not too hot. It's about 80 degrees, give or take. Not much. Now I'm going to add some calcium chloride to this. Now I'm going to see, is this going to heat up in temperature or get colder? All right, so if it heats up, that means there's energy entering the system. In that case, it'll be endothermic. If it's leaving, it'll be exothermic. So let's see, will this be endothermic or exothermic? It's 25 degrees. Let's see what's going to happen. Let's put this in there. Let's give a little bit of a stir, shall we? We definitely see it's heating up. In this case, we see that energy is entering the system. It's getting a little hot. About 40 degrees. Like I say right now, this stuff really does stink. It's boiled cabbage juice. I'm glad you're watching this on camera and not doing it in person because the smell. All right, about 41 degrees. All right, starting to get a little warm. All right, so we see the energy is entering the system. So in this case, it's entering, it'll be endothermic. All right, let's try another one and see what we get. You'll just wash off the thermometer there. Let's grab another one of these guys. In this case, I have a liquid here and a powder. Let's see, I think I lost my. Okay, let me go get a new one of these. Canister. All right, so I'm going to use a measuring cup here. And I'm going to first start off by pouring in the liquid. Okay, and I'm going to put my thermometer in here to measure it. Of course, now this thing cut off, but it's okay. You get time. So here we have clear liquid. This liquid is acetic acid. Nothing too dangerous, but again, since we're done with the chemicals, you want to wear safety glasses. And I have here sodium bicarbonate, also known as baking soda. All right, once it starts up, we'll do the experiment. Data collection. Set it on up. Guess also if we use a stylus. Set it up. Do this every couple seconds. I'm gonna actually switch to Fahrenheit this time. Usually we use Celsius in class. This way so you get better knowledge of it because you don't know Celsius yet, but we'll get there. Okay. So right now, this liquid is about 64 degrees. Now, if we add this baking soda in here, what's going to happen? Is we see some bubbles forming, which is a great indication of a chemical reaction is occurring. Now we see the temperature is quickly dropping. So that means through this gas was leaving, energy is also leaving the system. So this energy is leaving. We see by when we look over here, when it leaves, it's going to be exothermic. Awesome. It looks like my stuff's smearing a little bit. It's not a problem. All right, so this is still the last piece right here. So in the first part, we said heat moves from the surrounding into the system. So for exothermic, right, think of it exiting. This is going to be where heat or energy moves from the system into the surroundings. All right. Now I'm going to do one more illustration on here because I don't know about me, when I draw illustrations, it's going to help me remember this. So I'm going to go back to endothermic, and I'm going to draw a little doorway like this. Pretend it's a big old wall, whatever. Now I'm entering the doorway. When I enter, it's going to be endo. Now when I'm going to go down here, I'm going to exit this system. Let's say now I draw the same doorway. It's going to be exothermic. I really can't write at all today, can I? In this case, we're walking away. We're exiting. So if we're exiting, it's exothermic. If energy is entering, it's going to be endothermic. All right, so that's what we have for today. Right now, we're not going to fill any of this out yet until tomorrow when we're doing the last part experiment and the CER for this. We're going to do the question, which is when the test tube is heated up by the Bunsen burner, does this represent an endothermic or exothermic process? Not a reaction, but a process right now. We will go through reactions in a bit, but right now it's a process. Explain your reasoning. So before we write this part down, we actually come by and visit this, put some good stuff over here. We'll complete this, and then we'll move on to phase changes. All right. Thank y'all, and have a